All right, here we go with lesson 5 for matrices. So in our last lesson, we took a look at Cramer's rule for solving a system of two variables. We had with just x and a y, so we had two equations. Today's lesson is really the exact same idea, but with a system of three variables. So now we're going to see three equations with three different variables like x, y, and z, but the process is still the same as it was when we did the set of two. So here's kind of how that process went. Here's sort of the general layout. Let me give you this, and then we'll take a look at one with some real numbers involved. So here's sort of a general layout of what we would see if I had three equations with three variables. So I have x, y, and z are my three variables in all of these equations. The a, the b, the c, and the j represent any real number. So we have numbers sitting in those places. So if you remember from our last lesson, the numbers that sit in front of the letters, like a, b, and c, are what we would call coefficients. The numbers on the right are called constants because they're not attached to a letter. Where all this would start, just like in the last one, is I would first build a matrix with my coefficients. So if you see the 9 numbers that would be sitting over here on the left side, that's where all this would start. So we would start by building a coefficient matrix. So here's what that would look like. I'll pause real quick. So here you go. So if I took the 9 coefficients that are on the left side and threw them into a matrix, it would look like this. And we are going to name this matrix A. So that is my coefficient matrix. And so if I were to take the determinant of this coefficient matrix, whatever that number is, that number goes on bottom of all three of my setups. And so remember how that determinant process went. We did that in a couple lessons ago, where I would first start by taking my first two columns and I would repeat them, and then it's my downward diagonals minus my upward diagonals. And so that was the process to get the determinant. And so again, that's what's going to go on bottom of all of my setups. On top of all of my setups is where things would change depending on which letter I want to solve for. So if I wanted to solve for x, I'm going to take my x values, these guys, I'm going to replace them with my constants. So I would take j, k, and l, whatever those numbers are, and I'm going to put them into my x column, and then I'm going to leave the y and the z column alone. So remember, this is my x column, my y column, and my z column that you're seeing right there in that setup. So again, if I'm solving for x, I'm going to take those three numbers, I'm going to put them into my x column, and I'm going to leave the other two alone. And so that's what you're seeing right here in that setup. And then if I wanted to solve for x, I then take the determinant of this, divide it by this, and I get my answer for x. I'm going to do the same thing for y and z, but now if I want to solve for y, I'm going to take my three constants, put them into the y column right there, and I'm going to leave that one alone and that one alone, and so I get this look that you see right here. And then from there, again, I would take the determinant of this, divide it by this, and I get my answer for y. And then I got to do it one more time for z. So now I'm going to take those three, put them into the z column. I'm going to leave these two alone, and I'm going to get this look that you see right here. Take the determinant, divide it by that, and I got my answer for z. Remember that these absolute value brackets that you see represent a determinant. So anytime you see those, it describes a determinant. Let me show you one with real numbers, and that'll be it. So here's where all this would begin. If this is the original problem, I'm going to start by finding my coefficient matrix, the one that we call matrix A. So I'm going to take the 9 numbers that you see on the left. So this is 3, 4, and -1. This is -2, -3, and 4. This is 4, -1, and 1. And so you can see this matrix that I built right here with those 9 coefficients. I then need to find its determinant. So I start by repeating the first two columns so that I can go through my diagonal process. So then it's the downward diagonals, and that's what you're seeing right here, minus the upward diagonals. Those are the 3 pink ones, and that's what you're seeing. Those are the pink ones that I got right there. And so when I cleaned all that up, I'm coming away with a determinant of 61. So remember what we saw up above, that becomes the denominator for all three of my setups. And so, sorry, let me get this up here. So That's where the 61, 61, and 61 is coming from. So now if I want to solve for x, I'm going to take my three constants, the 9, the negative 14, and the negative 18, and I'm going to put those into the x column, and I'm going to leave the other two columns alone. So that's where you can see those two columns right there. I will then have to define the determinant of this, divide it by 61 to get the answer for x. And to get the determinant of this, it's the same process that I did right here. And so that's where the negative 183 came from. We're dividing it by 61 and I get my solution for x. Just got to repeat that process for y and z in order to get those answers, and that's it. So again, I'm taking those three numbers. They are now going into the y column. I leave my x's and my z's alone. I'm going to take the determinant of this, just like I did up here. That's where the 244 comes from. Divide it by 61, and you got your answer for y. And then one last time, I'm taking those three constants, 9, negative 14, and negative 18. They're now going into the z column. I'm leaving these two coefficient columns alone. Take the determinant of this, divide it by 61, and now you got your answer for z. And so that's our process. Again, you can take all three of those answers, plug them back into any one of those equations, and it should create a true statement if you did this right. So it's always a way of checking your answer for those.